All right, here are solutions for what ended up being our practice midterm. It's actually the midterm that I gave a previous Math 111 class. So it should give you a pretty good idea of what to expect. The format of your second midterm will be just like this one, in that you'll start with the true-false question, and then there'll be material from quiz 5, 6, 7, 8, 9, and then finally some extra credit. So the questions within those sections might differ slightly, but I think if all these topics make sense to you, that'll give you a good gauge of where you stand for our midterm. So without further ado, let's get started. The first thing you'll see on your midterm, either tomorrow or Friday, is a bunch of true-false questions. And the first of these, it's giving me a function, and it says, true or false, this function is an even function. What you need to know for that is kind of the definition of an even function. And as long as I'm here, I might as well tell you the definition of an odd function. So an even function is one such that f of negative x equals f of x. If you don't know what that means, that's okay. I'll explain it in just a second. An odd function is one in which f of negative x is equal to negative f of x. This might just look like a big jumble of symbols and stuff, but what this is saying is if I have a function f of x, I can always figure out f of something else. If I gave you this is f of x and I asked you for f of 3, for example, what you would do is replace all your x's with 3's, and you say, oh, 2 over 9? Sure, f of 3 is 2/9. Just like I can figure out f of 3, I could figure out f of negative x. The way you figure out f of negative x is you take your function, and everywhere you see the letter x, you replace it. But instead of replacing it with 3, since I don't want f of 3, I'm going to replace it with negative x. So instead of 2 over x squared, I got 2 over negative x squared. However, I can simplify that, because negative x squared just means negative x times negative x, and a negative times a negative is a positive, so what I end up with is just 2 divided by x squared. And the point that I want to make here is 2 over x squared is the original problem here, right? It's f of x. So what I've just shown by doing some simplification is that f of negative x is the exact same as f of x. That is the criteria for a function being even. So true or false, this is an even function? That's very true. Here's another one. This is saying true or false, this is an odd function. Well, let's see what happens. The test to see if it's an odd function is very similar to the test to see if it's even. In both cases, you want to figure out what f of negative x is equal to. So I have f of x. If you give me f of x, I can figure out f of negative x. What I do is I go through this formula, and everywhere I see the letter x written, I'm going to replace it with a negative x. So instead of x to the 6th, I got negative x to the 6th. And instead of x squared, I got negative x squared. And instead of the x on the bottom, I got negative x. And now what I want to do is simplify this thing and try to figure out, is that the same as the negative of f of x? Well, let's see, negative x to the 6th power, negative x times negative x times negative x 6 times. A negative times a negative is a positive. So since this exponent's even right here, negative x to the 6th power is the exact same as x to the 6th power. That's for the same reason that this thing on the bottom here is the same as x squared. And negative x to the 2nd power is the same as x to the 2nd power. But down on the bottom, I have negative x. This fraction right here, when you have a fraction like 1 divided by negative 3, that's the same as negative 1/3, right? A positive number divided by a negative number is a negative number. It's the same thing here when we're dealing with fractions. I have this thing up top divided by negative x. I could write that as the negative of, the thing up top, which is x to the 6th plus x squared plus 1 over x. Dividing by negative x is the same as the negative of dividing by x. And the reason I want to write it this way is because it's a little bit easier to see in this final step that what I have is the negative of f of x. Right? Because f of x is all this stuff. It's x to the 6th plus x squared plus 1 over x. And what's written here is negative that thing. So what I have is negative f of x. What I'm saying is f of negative x is the same as the negative of f of x. That's exactly my criteria for being odd. So in this case, this is also true. The point that I want to make here is it's not as simple as just looking at the exponents. Like this is an even exponent, so is the function even? Well, it turns out it is. But the test isn't quite that simple as this example here illustrates. Here I had even exponents, but the function ended up being odd. A little bit tricky. Okay, the graph of f of x equals x squared plus 3 has an x-intercept at 3. What I was going for in this problem is, maybe I'll switch colors so they don't run together too much. Anytime you're asked to figure out the x-intercept, what you do is you set y equal to 0. You can either just memorize that or understand that. If you want to understand that, the reason why is the x-intercept is asking my graph, I don't know what it looks like, maybe you do know what this looks like, but pretend you don't. My graph, whatever the hell it looks like, may cross this axis right here. This is my x-axis, this horizontal line. If it does, if it crosses this x-axis, here's one, crosses a few times, those points are called the x-intercepts. And the one characteristic that these 3 points all have in common is their height is 0. Right? The x value is different. This one looks like -1, and maybe this is -3, and this is +2. They have different x values, but each of them have a height or a y value equal of 0. So when I'm trying to find the x-intercepts, what I do is I make the y equal to 0, and then I solve. I start out by saying that the height is 0, and then I solve to figure out what the x's are. That's what we'll do over here. So if I want to figure out the x-intercepts for this equation, I would make y equal to 0. The f of x is the y. So I would say 0 equals x squared plus 3. And I'd solve this equation. If the answer I get for x when I solve is 3, then this statement is true. But that's not going to happen, right? If you try to solve this equation, maybe subtract 3 from both sides, there's no solutions here. You can't take the square root of a negative number. There's no number that when you square it, you get -3. Okay, that's not true. I guess if you're dealing with imaginary numbers, you could solve this equation. But the point is, the solution to this equation is not 3. 3 squared is not the same as -3. This does not have an x-intercept at 3. That statement is false. In case you're curious, turns out this has a y-intercept at 3. To figure out the y-intercept, you make the x equal to 0. If x is 0, I get y equals 0 plus 3. This graph has a y-intercept at 3, not an x-intercept at 3. False. All right, moving on. The next two ask about this thing called the discriminant. The discriminant is the thing that's underneath the square root sign when you're dealing with the quadratic equation. So b squared minus 4ac. And really there's kind of 3 cases. Either this thing is a positive number, it's a negative number, or it's 0. If b squared minus 4ac is a positive number, you get 2 solutions. If this thing is a negative number, you get no solutions. And if this thing is exactly 0, you get 1 solution. So what I need to do is calculate b squared minus 4ac in both of these cases. In this case, the a is equal to 5, the b is equal to -10, and the c is equal to 5. B squared minus 4ac, well, if you have this as your equation, the a is the coefficient on the x squared term, the b is the coefficient on the x, and the c is the constant term, has to be equal to 0. So in this case, a is 5, b is -10, c is 5, 5, -10, 5. And so if I figure out b squared minus 4ac, see b squared is -10 squared, which is 100. And from that I want to subtract 4 times 5 times 5. Well, if you multiply this all out, you get 100 also. 4 times 5 is 20, times 5 more is 100. You get 0. So what did I just figure out? Figured out that the discriminant here is 0. Anytime your discriminant is 0, that means you have 1 solution, 1 real solution. So this statement that this equation has 1 solution, that's very true. And it's because the discriminant was equal to 0. It doesn't ask you to find the solution, it just asks how many there are. Anytime you're asked how many there are, think discriminant. Think this thing right here. Next question, same thing. Just making sure that if you got it right on the last one, it wasn't a fluke. A is 5, B is -11 this time, C is 5. So if I figure out b squared minus 4ac, it'll be pretty similar to up here, right? A and c are the same. The only difference is b is now -11. -11 squared is 121. I end up with a positive number here. It ends up being 21. You don't care what number it is, just that it's a positive number. This number is greater than 0. Anytime your discriminant is positive, that means you have 2 real solutions. This has no real solutions. That's false. This actually has 2 real solutions, and I know that because the discriminant is a positive number. Finding those solutions is hard, but it doesn't ask you to find the solutions. It just asks how many there are. And again, anytime you're asked how many, think discriminant, this thing. Next one was some graphing. This point, this ridiculous point, they're saying it lies in the 4th quadrant. Really what this is testing is that you know what the 4th quadrant is. The way quadrants come up is when you're graphing points on your coordinate plane, kind of your x-axis, which is this horizontal guy, and the y-axis, this vertical guy, divides all the space into fourths. There's kind of 4 sections here. This one up here, when both the x and the y are positive, is called the 1st quadrant. Everything's positive. And then we label the rest of them by moving counterclockwise, meaning this is my 2nd one, this is my 3rd one, and this is my 4th one. So this point right here, I mean, you might not want to actually graph it because these numbers are huge, but if you just imagine that you graphed it, where would it show up? Would it be here, 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 or here? Well, let's see, its x-coordinate is negative 943, so that means I'd go to the left by 943. I'd be way the hell out here, and then I'd go up by 217. I'd end up somewhere here in the 2nd quadrant. This point, sure, if you draw the scales right, maybe it'd be up here. Negative 943 and 217. It's in the 2nd quadrant. It's not in the 4th quadrant. Statement's false. Guess I switched from red to green for some reason. Green to red. Okay, lines, perpendicular lines. We'll see more on this later. This question tests 2 things. First, it wants you to be able to figure out the slope of this given line. So if you note, this right here is given in slope-intercept form. It looks like y equals mx plus b. And the m in that m equals mx plus b is negative 2, the coefficient on the x term. What that means is this line right here has a slope of negative 2. But that's not what this question is asking for. This question is asking some other line which happens to be perpendicular to this line. They're saying what is its slope? And what you need to know is perpendicular means that the slope is the negative reciprocal. Sounds worse than it is. I'll explain it. So what I'm saying is the slope of the line that is perpendicular to this line has a slope that's equal to the negative reciprocal of this number. What is the negative reciprocal of negative 2? Well, the negative of negative 2 is positive 2, and the reciprocal of 2 is 1 divided by 2. So what I'm saying is that the line perpendicular to this line would have a slope of positive 1/2. This says it has a slope of negative 1/2. That's false. It has a slope of positive 1/2. It's the negative reciprocal. And then last, kind of goofy, stupid question. Everyone needs more math. Yeah, that's true, I guess. Whatever. Or put false. I don't care. Or put a joke, entertain me. I don't care. Do whatever the hell you want. Okay, material from quiz 5. Quiz 5 involved a lot of factoring. One type of problem that gives a lot of people trouble are factoring quadratic trinomials when the leading coefficient is not a 1. Sounds worse than it is. What I'm saying is, to solve this equation right here, I'm going to have to factor, as the instructions say. It only helps to factor if your equation is set equal to 0. The purpose in factoring is you're going to rewrite this as something times something else equals 0. And the reason why you want to do that is in math, the only possible way you can multiply together 2 numbers and end up with 0 as your result is if one of those 2 numbers is 0. Right? If this one's 3, this one better be 0. 3 times 1/3 is not 0. 3 times negative 3 is not 0. 3 times negative 1, there's no other way to get to 0 except for having this as 0. So what I'm saying is if we can factor this, if we can write it as a product of 2 things, we can draw some conclusions. We know that one or the other of those 2 things must be equal to 0 if we have our equation set equal to 0. The point that I was trying to make there is it doesn't help to factor unless this thing's set equal to 0. For your very first step, Subtract 10 from both sides of the equation. It's tricky the way it's written because you look at it and you're like, oh, there's a greatest common factor of x on the left. I can factor that out. You can, but it doesn't get you any closer to the answer because it doesn't help to factor the left-hand side if the right-hand side is not 0. So step 1, get it set equal to 0. Step 2, factor this thing. There's a couple different ways to factor this thing. Some people prefer to use this guess and check method. To be perfectly honest, I was taught the guess and check method when I was at school. That's how I learned how to do it. That's how I got through all my math classes doing it. I don't like that method because it's not easy to teach people to guess and check, and it freaks them out on a test to have to keep guessing and checking their answer. So there's another way you can do it. If you want to do the guess and check method, totally fine. Ignore the next 2 minutes of this video when I show you another way. Another way to do it is this 3-step process. Step 1 is to find two numbers that, and you're always going to be looking for two numbers that add to the coefficient on your x term. So add to 21 and multiply to the product of your leading coefficient and your constant term, 10 and negative 10. 10 times negative 10 is negative 100. So what I want is find two numbers that multiply to negative 100 and add to positive 21. Think about all the things that multiply to 100. 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. I think those are all the integer pairs that multiply to be 100. But I want negative 100, so one or the other has to be negative. So if you kind of go through that list that I just rattled off and look for a pair of them, one negative, one positive, that would add to 21, I think what you'll come up with is positive 25 and negative 4. Those add to 21, they multiply to negative 100. That's just step 1, that's not your answer. Step 2 is you're going to replace your constant term, 21x, with 25x minus 4x. 21x is the same as 25x minus 4x, right? 25 minus 4 is 21. So it's okay to replace this. We're not changing any values. How did I come up with this? That was step 1. Right? Those are the two numbers I found in step 1. What I'm saying is let's write this as 10x squared plus 25x minus 4x minus 10 equals 0. If you wrote minus 4x plus 25x, totally fine. You'll end up with the exact same answer. Step 3, factor by grouping. The way you factor by grouping is now that I have 4 terms, I can group them into 2 pairs of 2. So this first group, the red group here, has a greatest common factor of 5x. And if I pull out that 5x, what I'm left with is 2x plus 5. Right, 2x from here and 5 from here. And then this becomes, I call it the target, the thing in the parentheses here. It's what I want to end up with in the parentheses from my second group, from my green group. So I got to pull out something from this green group so that I'm left with 2x plus 5 in the parentheses. What that something is negative 2. Because if you factor out a negative 2 from negative 4x minus 10, you're left with 2x plus 5. So what you now have, it's hard to see it this way, are just 2 terms. I know it looks like 4 terms, but they're just 2. This one and this one. And each of those terms has a 2x plus 5 in it. So just like I factored out a 5x from each of these terms and wrote it once down here, I'm going to factor out a 2x plus 5 from each of these terms and write that once down here. If I factor out a 2x plus 5, this is gone and this is gone. All that I have left is 5x minus 2. And so what I now have is something times something equals 0. That's good, because as I was saying earlier, that means either the first thing equals 0 or the second thing equals 0. I now have 2 equations I can solve. Subtract 5 from both sides, divide both sides by 2. Over here, add 2 to both sides, divide both sides by 5. Get these 2 answers, which is the answer to this question. If you want to jump straight from here down to here, that's that guess and check method. Totally fine with me. I don't care at all. Just want to show you another way so you don't have to rely on that guess and check method. B, solve the following equation by either completing the square or using the quadratic equation. Okay, we just learned how to factor, which is great. You can factor this problem and solve it. The downside with factoring is not all equations factor. If your equation won't factor, what you have to do is either use this completing the square method or the quadratic equation. To complete the square, You first get your x squared and your x terms together on one side of the equation, constant over on the other side, so subtract 8x from both sides. Then you want to add some number to both sides of the equation. In this case, that number is 16. I'll explain in a minute where that comes from. And the reason you add 16 to both sides is because what you're then left with is a perfect square on this side of the equation. Instead of having the letter x written twice, I only have it written once, so I can solve for it. Left out some key steps there. How'd I get this positive 16? I guess I don't have to write it. This positive 16 right here is always half of this number, so half of negative 8, squared. Half of negative 8 is negative 4. Negative 4 squared is positive 16. That's always how you get the number that you write on both sides of the equation. How did I know that x squared minus 8x plus 16 was the same as x minus 4 squared? This is always x, and this is always half of this number. This number is negative 8. Half of that number is negative 4. X minus 4 squared. If you're not sure if you did this right, FOIL this all back out. Make sure you get x squared minus 8x plus 16. If I add 16 to this side, I have to add 16 to this side. That brings me to this step. If you can get to this step, you're actually really close to being done. Just got to isolate the x. Got to get rid of this square root or this squared sign. To do that, you take the square root of both sides of the equation. Be careful, anytime you take the square root of both sides of an equation, you have to put in a plus or minus sign. That doesn't mean that every square root means plus or minus. It means anytime you algebraically take the square root of both sides of an equation, you have to put in a plus or minus. Finally, add 4 to both sides. You get 4 plus or minus root 6. What that's saying is there's two solutions. One of them's 4 plus root 6, whatever that number is. The other one's 4 minus root 6. This is how you solve this by completing the square. There's also the quadratic equation. It's more of a memorization thing. It's knowing that solutions to formulas of this form are always this mess. If you can memorize all this, you can always use this formula and get the right answer. That'll always work anytime completing the square works when you can't factor. The downside to doing it this way is we'll see a problem later on this midterm that's not solving equations with circles where you have to complete the square. So it might be in your best interest to do it this way since we'll have to use this method later on. But if you want, you can do it this way too. That's fine. We got this equation. We need to get it into this form. So let's see, to make this look like this, what I'm going to do is I'm going to subtract 8x from both sides and add 10 to both sides. So I get that my a is equal to 1, my b is equal to negative 8, and my c is equal to 10. And if I plug that into this equation, I get x equals negative 8, which is positive 8, plus or minus the square root of negative 8 squared, which is 64, minus 4 times a times c. 4 times 1 times 10 is 40, all divided by 2 times 1, which is 2. And if I simplify that a little bit, I get 8 plus or minus the square root of 24 over 2. The square root of 24 is the same as the square root of 4 times the square root of 6, but the square root of 4 is just 2. So the square root of 24 is the same as 2 root 6. I can now factor out, I have two terms up in the top, this one, the 8, and this one, 2 root 6. I can factor out a 2 from both of those and cancel it with a 2 on the bottom, and what I'll be left with is 4 plus or minus root 6. Sure enough, the same thing I got over here. Two different ways to do these problems. I will not make you guess about when something factors and when you use the quadratic or complete the square. I will tell you. So the idea is factor up here because you can. Down here, don't try to factor, it won't work out. All right, another type of equation to solve are these radical equations. What makes these equations hard is this square root sign. If I could just get rid of the square root sign, I'd be in good shape. Well, I can get rid of the square root sign if I can isolate it. So your first step when you're dealing with these is to isolate your square root sign. All I'm saying is get it all by itself. Add x to both sides of the equation. Now that it's all by itself, I can square both sides of the equation and cancel out that square root sign. Now I don't have any square roots, so I can solve this equation. X plus 5 squared. It's a little bit hard to deal with, but what it means is x plus 5 times x plus 5. If you FOIL that all out, you'll get x squared plus 10x plus 25. And what I now have is something that kind of resembles a and b. Right? There's no square roots anymore. All I have are squared terms, x terms, and constant terms. Problems of that type, I know how to solve them. Set it equal to 0. So let's add 2x to both sides and subtract 5 from both sides and get x squared plus 12x plus 20 equals 0. Added 2x to both sides, subtracted 5 from both sides, and I have it equal to 0. Now I have an equation I have to solve. How do you solve this? Well, it kind of depends. There's 3 different methods you can use. I didn't specify, so you can do whatever the hell you want. You could do this method, factoring. You could do completing the square, or you could use the quadratic equation. Typically what I do is I try to factor first because I think that's the easiest. So I look at this and you're like, wait, that wasn't the easiest. We did that up here and it took forever. It was this 3-step process. Right, it's hard when your leading coefficient is not a 1, when it's 10 like this. When your leading coefficient is a 1, it's quite a bit easier. So there's a 1 right here. If it's going to factor, it's going to factor into this form right here. It'll be, I just need to find 2 numbers that multiply to 20 and add to 12. So it's similar to what we did in A, but not quite the same. Find 2 numbers that multiply to 20, add to 12. Well, let's see, 20 is 1 times 20, doesn't help. 2 times 10, that seems like a good one, right? Those add up to 12, multiply to 20. Write the 2 here, write the 10 here, and you factored it. Jumping from here to here like that only works when the leading coefficient is a 1, so be careful with that. What I now have is something times something equals 0. That's good. That means either the first something equals 0 or the second something equals 0. You can solve them and get these 2 answers. If you get to here, I'm pretty damn happy. Depending on how other people do, you might get full credit just for getting here. But to be safe, if a lot of people get this next step right, then I'll take off a point if you just stop here. Anytime you have radical equations like this, when you have square roots, you want to check your answers. Not check them to see if you screwed up some step in here. Check them to see if information was lost in this process. Okay, that seems a little bit complicated, but what I'm saying is if we check -2, let's see, 5 minus 2 times -2, does the square root of that thing minus -2 really equal 5? Well, let's see, -2 times -2 is positive 4. 5 plus 4 is 9. The square root of 9 is 3. 3 plus 2, yep, that equals 5. Nice, it looks like this answer really works. What if we check x equals 10? 5 minus 2 times -10. Does the square root of that minus -10 really equal 5? I don't think it's going to work, right? This is -2 times -10 is positive 20. So what I have over here is the square root of 5 plus 20, the square root of 25. But 5 plus 10 more? No, that's not 5. Right, that's 15. That doesn't work. This is, maybe I'll say, like, not a solution. This is my only answer in this case. You don't always have to check your answers, but in these radical equation ones, you do want to. If you're curious, it was going from this step to this step where we lost the information. If you plug in -10 here and here, you'll say that they're equal. But if you plug in here and here, they're not equal. And the reason why is when you square both sides of the equation, you can make things that used to not be equal become equal. What I'm saying is if this is -2 and this is positive 2, when I square both sides, they both become 4. They become equal, even though they're not equal. Whatever. You don't need to know why that is. You just need to know when you see a radical, check your answers to get that last point or something. Okay, quiz 6. Quiz 6 was a lot of inequalities. So the material that I chose on this midterm from quiz 6 was solving a bunch of inequalities. First one, absolute value inequalities. I think the easiest way to do these is to first set it up as an equality, change this sign into this sign, then isolate the absolute value, and then solve this equation by getting rid of the absolute values. The way you get rid of the absolute values is you have to kind of imagine, okay, this 3 minus 4x thing, if this is a positive number, then the absolute value signs aren't doing anything. And I just get 3 minus 4x equals 2x plus 10. But if this whole thing, I don't know what x is, so I don't know what this whole thing is. But if x is such that this entire thing becomes negative, then what the absolute value signs are going to do is they're going to change the sign of this entire thing. Mathematically, the way you say change the sign of is you multiply it by -1. So if I'm in the case where this thing is negative, if I'm going to not write the absolute value signs, I better take care of what the absolute value signs would have done, that is change the sign. Now I have two equations that don't have absolute value signs, so I can solve them. Add 4x to both sides, you get 3 equals 6x plus 10. Subtract 10 from both sides. Yeah, I would have thought these numbers would work out nicer, but I guess they don't. -7 equals 6x. So divide by 6 and you get x equals -7/6. Over here, if we distribute this -3, we get -3 plus 4x equals 2x plus 10. Subtract 2x from both sides. Add 3 to both sides. And we get x equals 13/2. Did I screw anything up? I'm surprised these are all fractions. I guess I just felt mean when I wrote this quiz and threw fractions in there. That's fine. We can deal with fractions. Okay, these are not your answers because these are the answers to when does this thing equal 10. We're not interested in when this thing equals 10. We're interested in when it's greater than 10. So what we got to do is set up a number line. Here's all the possible numbers. I want to know which numbers make this thing true. I don't have to test all of the numbers. I just have to look at a couple of them. So -7/6, maybe that's out here on my number line, and 13/2, that's over here. Those 2 points divide my number line into thirds, into 3 regions. What I can do is test one number from each of those 3 regions. And if that number works, then every number in that region works. So I need one number in region 1, one number that's less than -7/6. -2, sure. It's arbitrarily, choose any number you want that's less than -7/6. -2, and throw that in here and see if it works. Well, let's see, the absolute value of 3 minus 4 times -2, which is 3 plus 8, minus 2 times -2. Question is that greater than 10? Or is that greater than, not 0, 10? I think it is. This is 11. Absolute value of 11 is 11 plus 4 is 15. Yep, that seems to work. These numbers are part of my solution. What about region 2? Pick any number you want that's in region 2. The easiest number that's between these two values, 0. I'm going to choose 0. You can choose any number you want in between these two numbers. Don't choose an endpoint. Choose any number in between them. Let's see, absolute value of 3 minus 0 minus 0. Is that greater than 10? No, it's not, right? This is 3. 3 minus 0 is 3. That's actually less than 10. It's not a solution. It's not greater than 10. These numbers aren't going to work. Finally, test a number that's greater than 13/2. Okay, because I was kind of a jerk and did fractions, it's hard to tell. 13/2 is, what, a little less than 7? 6.5? Pick any number bigger than 6.5. How about 10? Nice round number. Absolute value of 3 minus 4 times 10, 3 minus 40, minus 2 times 10. The question is that greater than 10? Well, 3 minus 40 is -37. -37, the absolute value of that is positive 37. And 37 minus 20, yeah, that's 17. That is greater than 10. That's true. These are solutions. So what that tells me is that my solution is all the numbers in region 1 and all the numbers in region 3. If it didn't tell me to use interval notation, I could just say that, maybe even draw this picture and trust that the grader knows what I'm talking about. I'm the grader. But since it says interval notation, let's write it in interval notation. Everything from negative infinity, maybe you prefer the infinity sign, I don't care, you can do whatever you want, all the way up to negative 7/6. However, I don't want to include negative 7/6, so I'm going to leave this parenthesis open because I want it to be strictly greater than, not greater than or equal to. Here's region 1. I don't want region 2. I do want region 3. Region 3 is everything from 13/2 all the way up to infinity. This thing right here is my answer. This one, similar. When you have, these are called rational functions, what you want to do is first set them relative to 0. That's already done. Then factor the top and the bottom. Well, then figure out when the top and the bottom equal 0. X squared minus 5x equals 0. X minus 2 equals 0. And those 2 points will be, or maybe 3 if there ends up being 3 answers, will be these boundary points that divide up my number line. Then I can test numbers in my number line, figure out what my answer is. So let's solve these. To solve this one, I could factor out an x, the greatest common factor there. Now I got something times something equals 0. That means either the first something equals 0 or the second something equals 0. So either x equals 0 or x equals 5. Over here, just add 2 to both sides and get x equals 2. So what I got for B here is 3 solutions, 0, 5, and 2. So when I draw my number line, 0, 2, 5, I'm going to end up with 4 regions, right? I got a region out here, region here, region here, and a region here. And what I got to do is figure out if numbers from each of those regions work or not. So test them. If you take a number less than 0, -1 for example, so it kind of helps to rewrite this thing in its factored form. X times x minus 5 divided by x minus 2. Right? Instead of x squared minus 5x, I'm going to write it in the factored form. And why that helps is if you look at region 1 are negative numbers. X is negative. A negative number, I don't care which one you choose, minus 5 more, that's still going to be negative. A negative number minus 2 more, that's going to be negative. So if I plug in any number in region 1, I'm going to get a negative times a negative divided by a negative. Say a negative times a negative is a positive. A positive divided by a negative is a negative. So what I'm saying, that looks like a division sign. I don't know if that's any better, is that when I plug any number in region 1 up into this equation, the left-hand side is negative. Negative numbers are not greater than or equal to 0. What that means is none of these will be solutions. What about numbers between 0 and 2? So the number 1, for example. Well, the number 1 is positive, but 1 minus 5 is negative, and 1 minus 2 is negative. So in this case, I get a positive times a negative, which is a negative, divided by a negative. A negative number divided by a negative number is a positive number. So when I plug in any number between 0 and 2, the left-hand side of my equation is a positive number. What positive number? I don't care. A positive number, any positive number is greater than or equal to 0. These numbers work. What about numbers between 2 and 5? I don't know, 3, for example. Well, let's see. 3, if I plug it in for x, is a positive number. 3 minus 5 is a negative number. 3 minus 2 is a positive number. So now I got a negative times a positive divided by a positive. Negative divided by a positive is a negative. Negative numbers are not greater than or equal to 0. These guys don't work. Finally, region 4, some number bigger than 5. 6, sure. 6 is a positive number. 6 minus 5 is a positive number. 6 minus 2 is a positive number. Positive times a positive is a positive. A positive divided by a positive, sure enough, is a positive. Any positive number is greater than or equal to 0. These numbers work. My answer are the numbers in region 2 and the numbers in region 4. You see this greater than or equal to, and you're like, oh, right, and that means I include all the endpoints too. Right? You think it's everything from 0 to 2 and from 5 to infinity, including 0, 2, and 5. Actually, you don't want to include 2. It's a little bit tricky. You don't include 2 because 2 is not in the domain over here. 2 minus 2 is undefined. So you got to be careful there. We're not going to include 2. I'm going to write my answer as everything from 0 up to 2. I'm going to include 0, but not 2. And then I'm going to include everything from 5 up to infinity. If you had included 2, actually I can tell you that people that included 2, I gave them full credit on this problem and wrote a little note. Hey, by the way, that's actually not in there. Not a big deal, just something I wanted to mention. The standard is to never include infinity because it's not a number, it's like a concept. But if you included it, I probably would write a little comment being, hey, by the way, there should be a parenthesis, but I wouldn't take off any points. All right, moving on, quiz 7. Quiz 7, I referred to this one earlier. This is kind of the circles quiz. What you need to know about a circle is that the circle with a center at the point HK and radius R will look like this. This thing that I'm writing right now is what's called the standard form of a circle. So what I'm saying is, if I could rewrite this so that it looked more like this, I'd be able to tell you, oh yeah, it's a circle and its center is at some number, depending on what these numbers end up being, and its radius is some other number. So I want to do algebra to rewrite this so that it fits this form. All right, it's kind of like in this true-false question, where because this wasn't a special form, I could just look at it and say the slope is -2 because it's in this standard form. If I could get my circle into the standard form of a circle, I could just look at it and tell things about it. Not the slope, but the center and the radius, because slope is a concept that just applies for lines. So what you need to know is, okay, first we got to rewrite this thing. The way you rewrite this is by completing the square. So earlier when I talked about completing the square and how it might be worth learning how to do it, is for this problem right here. So what you do is you're going to actually complete the square twice. I got x squared plus 3x. I'm going to have to complete the square. I'm going to have to make this a perfect square. I got y squared minus 5y. I'm going to have to make that a perfect square. And I got this 7 over here. So I want to look at this and I want to add some number to both sides of the equation that makes this a perfect square. The number that you will add to both sides of the equation will always be half of this number squared. Half of 3 is 3/2. 3/2 squared is 9/4. So it's 9/4 that I add to both sides of the equation. That didn't make sense? All right, I'll do it again. This number right here is -5. Half of -5 is -5/2. -5/2 squared is 25/4. So 25/4 is the number that I am going to add to both sides of the equation. What I now have is a perfect square here and a perfect square here and some number here. What those perfect squares are equal to, well, it turns out this one is x plus 3/2 squared, and this one is y minus 5/2 squared. How did I know that? Well, two ways. The harder way, if you FOIL this all out, you'll see that you end up getting back here. Try it out. FOIL this, x plus 3/2 times x plus 3/2. You'll get this. But you probably don't want to do that on the test because it's kind of a guess and check thing. A better way to do it is this number is always half of this number. Half of 3 is 3/2. Half of -5 is -5/2. So I think this is one of those instances where it helps to just memorize where the pieces come from. Memorize the method so that you can reproduce it on the test. Over here, yeah, okay, I guess I need to get a common denominator. This is 7/1, so I could say it's 28/4. So what I have is x plus 3/2 squared plus y minus 5/2 squared is equal to 28 plus 9 is 37. 37 and 25 is 62. Right. Surprised I didn't make this a perfect square. Maybe I meant to. I can't remember. Anyways, it doesn't matter. If it's a perfect square, it's easier to see what the answer is. But in this case, it's not. That's okay. This is the standard form right here. If you want, you can reduce this fraction. You don't have to. This is the standard form. So I got to look at this and figure out what is h, what is k, and what is r. Look at this thing in red and this thing in blue and compare them. What in blue is playing the role of this red h? Well, let's see. This says x plus 3/2. This says x minus h. Instead of x plus 3/2, I could imagine it says x minus negative 3/2, because plus 3/2 is the same as minus negative 3/2. So what's playing the role of h is negative 3/2. What's playing the role of k? This says y minus 5/2. This says y minus k. So k is the 5/2. What's playing the role of r? Well, this thing right here is r squared. Right? 62 over 4 is r squared. I don't want r squared, I want r. If 62 over 4 is r squared, then r is equal to the square root of 62 over 4, or the square root of 62 over 2. This is the center, this is the radius. Note that this is negative 3/2 and this says positive 3/2. This is negative 5/2 and this is positive 5/2. That always happens. The coordinates of your center will be the opposite sign-wise of these two numbers. And that's because we have these negatives in the formula. I put a problem like this on your midterm. I believe I chose it carefully with the fractions so that this turns out to be a perfect square. If this, instead of being 62/4, was, let's say, the number 9, then you would say r equals 3 instead of having to do this mess. This one, part B, is actually quite a bit easier than part A. Part B, you just have to look at this and identify that this is a circle. That's easy. Its center is at the point 2, negative 5. Right, the x-coordinate of the center is 2, the y-coordinate is negative 5. And its radius, which is the distance from the center to the outside, it looks like it's 1, 2, 3. You can identify all this. We can grab this thing in red right here and replace the h with the 2, the k with a negative 5, and the r with the 3. We can say x minus 2 squared plus y minus negative 5, in other words, y plus 5 squared, equals 3 squared, or 9. So right here is the equation of this circle right here. I guess I should write, this is my answer for this above one. These, easier than these. It's harder to kind of go from the equation to the information than going from the information to the equation. This is just depends on you having this thing memorized or understanding all the pieces. Okay, this problem. A set of points, and you can be asked whether they define a parallelogram, a rectangle, or a right triangle. A parallelogram is a shape with two. The good news is that the method you'll use on all three is basically the same. A parallelogram is a shape with two sets of parallel edges. That, for example, these are parallel, these are parallel. A rectangle is like a parallelogram. It's got two sets of parallel edges, but now they form right angles. These are perpendicular to these. And a right triangle is a triangle where two of the sides are perpendicular. If you know that, you can do any of these types of questions. What you do is, instead of drawing these things, well, it might help to draw them just so I have something to reference. See, the point 0, 0 is right here. The point 3, 1, 1, 2, 3, 1 is somewhere in here. The point 1, 7, 2, 3, 4, 5, 6, 7, somewhere way the hell up here. And the point negative 2, 6 is way up here. It's a very poor drawing, but I end up with some shape that looks something like this. The question is this a parallelogram? Well, it's a parallelogram if this is parallel to this and this is parallel to this. The way you can figure out if things are parallel, lines are parallel, is if they have the same slope. So this is A, B, C, D. This was A, B, C, D. What I can do is I can start calculating slopes. I can calculate the slope of the line between A and B. This slope right here. The slope is the change in the y-coordinates over the change in the x-coordinates. So the y-coordinate here is 0, And from that, I want to subtract the y-coordinate here, which is 6, and divide that by the x-coordinate here is 0. X-coordinate here is negative 2. And so what I get is negative 6 over 2, or negative 3. That by itself doesn't really tell me anything. It tells me the slope is negative 3. But I can then compare that with the slope of this line, CD. I'm hoping this will be negative 3 also, and then I'll have one set of parallel sides. Well, let's see. y2, can make this y2 minus y1 over x2 minus x1. I get 6 over negative 2. Sure enough, I get negative 3 again. Got parallel sides. I'm halfway to saying that I have a parallelogram. What I now need to do is make sure these two lines are parallel also. So let's see the slope between A and D. Let's see, the y-coordinate for D is 7 minus the y-coordinate for A, which is 6, divided by the x-coordinate for D, which is 1, minus the x-coordinate for A, which was negative 2. 7 minus 6 is 1. 1 minus negative 2 is 3, 1/3. That means this right here has a slope of 1/3. What about this right here? Well, the slope between B and C, y-coordinate is 1, minus y-coordinate is 0, x-coordinate is 3, minus x-coordinate, which is 0, 1/3. Same. And this is MBC. What I just showed is I have two sets of parallel lines. So does this define a parallelogram, or show that it does? I guess I already knew it did. Yes, it does, because I have two sets of parallel sides. Furthermore, you don't need to write this. It's a rectangle. So not just a parallelogram, it's also a rectangle, because those sides are perpendicular. How did I know they were perpendicular? By looking at this fancy picture here and saying, oh, that looks like it's perpendicular? No, because to be perpendicular, as we talked about somewhere up here, the slopes have to be negative reciprocals of each other. The negative of negative 3 is positive 3, and the reciprocal is 1/3. So the negative reciprocal of negative 3 is 1/3. The negative reciprocal of 1/3 is negative 3. Because they're negative reciprocals of each other, they're perpendicular. You didn't need to write this parenthetical stuff. All you needed was the stuff above. Okay, material from quiz 8. I think there's 2 more to go. Slope-intercept form of this line. So when you are given the slope and a point, it helps to use this thing called point-slope form. The way I think of point-slope form is as a means to get things into slope-intercept form. Slope-intercept, probably a little bit more familiar to you. It's also called the standard form of a line. It's y equals mx plus b. Point-slope form is a little bit uglier, but it's better suited for this specific problem. It's better suited for any time you know the slope and one point. Here I need to know the slope and the y-intercept. This point is not the y-intercept. So I use point-slope form. I say, let's call this x1, y1, and m. I say y minus y1 equals m times x minus x1. So I got y minus 3 equals 2/3 x plus 5. I guess that's right. Determine the slope-intercept form. So it wants me to write it like this. It's not like that, but at least I have an equation. I can algebraically solve this thing so that it's an equation so that it fits this form. The way I do that is I'm going to take this 2/3 and distribute it through. Then I'm going to add 3 to both sides of the equation. 3 is the same as 9/3. 9/3 plus 10/3 is 19/3. Gave him a lot of fractions on this midterm. Slope-intercept form of this line, this guy right here. I used point-slope form, even though it didn't specifically say anything about that in the problem, because point-slope form is a good means of getting to slope-intercept form when you have the slope and 1 point. Okay, B is pretty similar. It says slope-intercept form, so I want a y equals mx plus b thing again. It gives me a point again. I'll call this x1 and y1. Bad news is it doesn't give me the slope. If it gave me the slope, it would just be asking question A over again. Fortunately, it tells me that it's perpendicular to this line. The line from 5A had a slope of 2/3. So if this line is perpendicular to that, this slope has to be equal to -3/2. Because remember, perpendicular means the slope is the negative reciprocal. The negative reciprocal of 2/3 is -3/2. What I now have is a slope and a point. I can repeat these steps. I can say y minus y1 equals m times x minus x1. y1 is -5. M is -3/2. X1 is 2. So I got y plus 5 equals -3/2 x. -3/2 times -2 is +3. This is -2 over 1. -3 times -2 is +6. 6 over 2 is 3. Anyways, subtract 5 from both sides. Get -3/2 x minus 2. Slope-intercept form of the line described, this guy right here. Okay, one more. Determine the x and y intercepts for the line that is parallel to the line from 5A. Okay, remember the line from 5A had a slope of 2/3, and parallel means you got the same slope. So my slope down here is 2/3. It tells me it goes through this point, so I can again use point slope form. Y minus y1, which is -5, equals m times x minus x1, which is 2. So y plus 5 equals 2/3 x minus 4/3. So y, if I subtract 5 from both sides of the equation, well, let's see, 5, I'd want a common denominator, so 5 is the same as 15/3. So -4/3 minus 15/3 is -19/3. I thought it would be a good idea to write it in slope-intercept form. You actually don't have to do that. The advantage of slope-intercept form is 2/3 is the slope, -19/3 is the y-intercept. So if you just recognize that the b in y equals mx plus b is the y-intercept, then you get this answer. It also wants the x-intercept. As we talked about earlier, the x-intercept you get by setting y equal to 0. So 0 equals 2/3 x minus 19/3. If I solve this equation, I'll get my x-intercept. To solve this equation, add 19/3 to both sides. Multiply both sides of the equation by 3/2. And what you get is x equals 19/2. If I lost you in that last step, multiply both sides of the equation by 3, these denominators go away. Then divide both sides by 2, and you get 19/2. There's your x-intercept, there's your y-intercept. And I'll write you can also express your y-intercept as 0, -19/3, and you can also express your x-intercept as, I don't know where I'll write it, maybe I can squeeze it in at the bottom here. Maybe I won't even bother. I'm happy with this is your answer and this is your answer. If you want to write them as coordinate pairs, as 0, -19/3 and 19/2, 0, go for it. You'll get full credit either way, if you leave it just like this or write it that way. I don't care. All right, finally the last problem. You'll get a graph, and they'll ask you a bunch of questions. So first, domain and range. What you need to know is that the domain is all possible x values. So because I have arrows at the end of this graph, that's really important. Make sure you look at those. That means it continues out to the left forever and continues out to the right forever. The domain is all of the possible x values, all the left and right. Since it goes to the left forever and to the right forever, my domain is all real numbers. It says interval notation, Fine. My domain is everything from negative infinity up to infinity. Range is not. Range, you kind of flip things sideways. The range is all the possible y values. So this arrow goes on forever, as does this one. So it goes up as high as I ever need, but it never goes below -3. Right? The lowest this graph ever gets is -3. So it's everything from -3 all the way up to infinity. Note that I included -3 because it does get to -3. This point should be in the range. So I include it here. And then it goes up as high as I want, so it goes up to infinity. Express the intervals of x on which f is increasing. This screws with people not because they don't know where it's increasing. I mean, you can just look at this thing and be like, oh, it's increasing right here, and then it's increasing over here. That's good. It's good to be able to see that, but it wants the intervals of x. It wants you to describe those 2 points according to their x-coordinates. So the x-coordinate here is -2. The x-coordinate here is -1. So what we'll say is it's increasing on this interval from -2 to -1, and it's also increasing on this interval. This x-coordinate is 2, and it goes off to infinity. I guess I've been using the infinity symbol, so I should use that. So really the thing I want to stress here is you look at this, and when it asks about increasing, you're thinking about going up and down, so you look at this and you tell me about its y-coordinates. I don't want to know its y-coordinates, I want to know its x-coordinates. The way you specify increasing, this will be important in calculus later on, is according to its x values. So that's why it's important that you give your answers in x values here. Same thing here. Express the intervals of x on which f of x is less than or equal to 0. You could probably look at the graph and tell that, oh, the f of x is the y. So where is it less than or equal to 0? Well, it's equal to 0 here, it's equal to 0 here, and it's less than 0 all throughout here. So all of that blue area is where it's less than or equal to 0. But again, you want to say the x-coordinates. So the x-coordinate for this point, I don't know, it's a half or so. The x-coordinate for this point looks like it's 4. And because I want less than or equal to 0, I'm going to include those 2 points. So I'm going to put brackets in. Last 2 questions. These 2 are hard because people confuse them. This one means x is 3. X is 3. What is y? I don't know if that was worth writing, but that's what this question is asking. This one is saying, what is x that makes, I don't know if this is English anymore, that makes y equal 3. F of x is the y. This is telling you that y is 3. It wants to know what x is. So this one is saying x is 3, give it the y. This one is saying y is 3, give it the x. So x is 3, what is y? Well, let's see, x is 3 right here. Maybe I need another color. Sort of running out of colors. X is 3 right here. It looks to me, I've kind of drawn over my original graph so I can't read it anymore. But it looks like when x is 3, I'm somewhere in here. And it looks to me like the height right here when x is 3 is about -1.5. I'm going to say x is approximately -1.5. Note it said estimate, so you just have to take a ballpark. Something close to that is good. Don't confuse that with this one. It's very similar. This is saying the height is 3. What different x's have a height of 3? The height is 3 right here. Looks like this x-coordinate has a height of 3, and this x-coordinate has a height of 3. And then I guess there's another one out here that has a height of 3. So 3 different answers. This guy right here, it looks like when my x-coordinate is -3, I have a height of 3. Looks like when my x-coordinate is -1, I have a height of 3. And then this one out here, I gave people full credit whether they got this last one or not because it's not even on the graph. But technically there should be one at 6 also, right? When x is 6, it looks like the height is 3 since this arrow just continues up forever. So I guess the answers here would be, well, the different x-coordinates that give me a height of 3 are -3, -1, and +6. And again, if you didn't put +6, I gave this exact test. I remember grading it. Most people didn't put 6 in. It's fine. I gave them full credit anyways. I wasn't trying to trick people. It's just I come up with these graphs by going to Google and typing graph of function, and it gives me hundreds of them, and I pick one of them, and then I use that one to try to ask questions about. So sometimes you get issues like that I got to be a little careful on. Okay, that's the end of the midterm. Just like you will see on your midterm, there will be an extra credit question. It won't necessarily have anything to do with this extra credit question. It's just a question that I thought was interesting that I didn't think was fair to ask you to do for credit. Too hard. But if you have time at the end, you might want to try the extra credit problem. It's worth 10 points. And this is what's going on with this one. It says I have this point at -3, 2. So here. And I got another point at 1, -6. 1, 2, 3, 4, 5, 6. Got this point right here. And what it's saying is there's some other point, x, 0. So the height of this other point, maybe I'll draw it in red, is 0. I don't know where this point is, but I know that it has a height of 0. And these 3 points give me a right triangle. So I said that there's 4 possible values of what x can be that will make this a right triangle. So what I'm saying is one of them would be, I don't know, somewhere out here. There's a right triangle. Yeah, I can kind of see that. So it's figuring out what this point is right here. And what this is saying is there's 3 other ones that you can write in here and get the answer. How do you do it? Well, we kind of do it the way we learn to do these problems, where you calculate the slopes. So what I'm saying is let's call this A, this B, and this C. The slope between A and B is, I don't know, well, I know the y-coordinate is 0, so I can say it's 0 minus 2. But for the x's, I don't know what this x-coordinate is, but I can just write x minus -3. In other words, it is -2 divided by x plus 6. And I could figure out the slope between B and C. That one's a little bit easier because at least in that one I know all the numbers. Let's see, y2, maybe I'll make that -6 minus 2 divided by 1 minus -3. That's -8 over 4, which is -2. And then finally the slope between A and C, well, let's see, 0 minus, I'll write it out, 0 minus -6, that's the change in the y-coordinates, and x minus 1, that's the change in the x-coordinates. I guess 6 over x minus 1. So in order for this to be a right triangle, these guys need to be perpendicular, or these guys need to be perpendicular, or these guys need to be perpendicular. So what I'm saying is there's 4 possibilities. Well, let's see. Maybe I'll come down a little bit. AB perpendicular to BC. This is the sign for perpendicular. Well, let's see. AB was -2 divided by x plus 6. BC is -2. If these two are perpendicular, then this slope is the negative reciprocal of this guy. The negative reciprocal of -2 is +1/2. I can solve this equation by multiplying both sides by cross multiplying. You get -4 equals x plus 6. And then if you solve this, if you subtract 6 from both sides, you get that x equals -10. What that's saying is that if I put a dot way out here at -10, somewhere out here, then I would create a right triangle. You can kind of see it there. It looks something like this, of a right triangle. Okay, there's one of the answers. What about if AB was perpendicular to AC? Well, let's see. AB is -2 divided by x plus 6. If this is going to be perpendicular to AC, this has to be equal to the negative reciprocal of this guy. The reciprocal of this is x minus 1 over 6. I want it to be equal to the negative reciprocal of this guy. Gives me this equation. Solve this equation. What you end up with is 12 equals x minus 1 times x plus 6. So 12 equals x squared. If you FOIL this all out, you'll get plus 5x minus 6, which we can solve by subtracting 12 from both sides and then factoring. I want two numbers that multiply to negative 18 and add to positive 5. Not sure two numbers exist. Did I do that right? Zero minus negative 6 is 6, x minus 1, and then this was 0 minus 2, x minus negative 3. Oh, because I screwed up. X minus negative 3 is x plus 3 here, not x plus 6. Shoot. So this should have been x plus 3. This should have been x plus 3. God. It's a lot easier to learn when your teacher doesn't screw stuff up. This should have been x plus 3. Subtract 3 from both sides, you get negative 7 is equal to x. I think that's going to make this work out better. This will be x. What am I doing? This will be x plus 3. So when I FOIL these guys together, I'll get x squared minus 2x plus 2x minus 3. And when I subtract 12 from both sides, I'll get x squared plus 2x plus 15 equals 0, minus 15 equals 0. You can tell it's the end of a long day when I start making this many mistakes. So this we can factor to solve. Two numbers that multiply to negative 15 and add to 2 are positive 5 and negative 3. And so what that tells us is either x plus 5 equals 0, in which case x equals negative 5, or x minus 3 equals 0, in which case x equals 3. And so what we get are two more solutions down here. And then finally, we've looked at when AB and BC are perpendicular. When AB and AC are perpendicular, finally we can look at when BC and AC are perpendicular. Well, the slope between A and C is 6 over x minus 1. I want that to be equal to the negative reciprocal of negative 2. The negative reciprocal of negative 2 is 1/2. So I want to solve this equation here. If you cross multiply, you get that 12 equals x minus 1. Add 1 to both sides, you get x equals 13. On this specific extra credit question, I asked to find two of them. So most people that got it right found this one and this one. Although to be perfectly honest, I don't think most people got this one right. Probably made it a little bit too hard. So take that into consideration when you're studying. This extra credit problem, probably a little bit too hard. That's why I made it extra credit. Your extra credit question, it's not like it's going to be like this with different numbers. Completely different topic. In fact, it's unrelated to geometry, if I remember right. So yeah, there you go. There's this midterm. I hope that helps you for studying. Again, your midterm will look very similar to this in terms of layout, but not necessarily the exact same in terms of content. But I will end this video here.